sketching an angle in standard position. In order to work a little bit more carefully with angles, our next goal is to introduce a way of dealing with angles inside of the standard coordinate plane. So let's sketch out some coordinate axes, put our x and y-axis in, and the general rule for an angle on the coordinate plane is that angles are measured counterclockwise or right-handedly from the positive x direction. What I mean when I say from the positive x direction is that one side of the angle is going to be the positive x-axis, and the vertex of the angle is going to be at the origin of the xy plane. Counterclockwise, you're probably familiar with. I also mentioned this as right-handed. So take your right hand and put it on the screen or on your paper where you're jotting this down, with your right thumb pointing up along the origin. And notice that the fingers in your right hand naturally curl in a counterclockwise direction. Most of the angular facets of analytic geometry, most of the parts of dealing with graphing that have to do with angles, are going to be in a right-handed orientation. And I'll mention it every time it comes up, but the basic idea is if you take your right hand and look at the way your fingers curl in your right hand, that's probably the direction that we care about looking. Right. But we measure an angle from that positive x-axis, and that gives us the terminal side of the angle. Most students coming into a pre-calculus course are a little bit more familiar with degree measure. And I'll just point out that in degree measure, a 0-degree angle would be along the positive x-axis. A 90-degree angle will be up here on the positive y-axis. 180 degrees is halfway around the circle. That's over here. Going or 3/4 of the way around the circle down at the negative y-axis would be 270 degrees, and then all the way around full circle is 360 degrees. Again, measuring counterclockwise from the positive x-axis. We could also do a negative angle if you so desired. So if I measured going this way, then down here at the negative y-axis would be negative 90 degrees. The negative x-axis, in addition to being positive 180 degrees, would also be negative 180 degrees. You can get negative 270 degrees up here at the positive y-axis, and you can get negative 360 degrees over here at the positive x-axis, making a full loop going backwards. You can keep going from there, but that's another video. We can do the same thing with radian measure, which is probably something you're a little bit less familiar with at this point, but you'll get there with all the practice that we're looking at in the rest of this course. All right, so we are measuring from the positive x-axis. We're going counterclockwise because that's what an angle in standard position looks like. And we're starting with 0 radians over here. And we know that a complete loop is going to take us to 2 pi radians. Right, so halfway around the loop over here on the negative x-axis would be half of 2 pi. which is pi. And this is really what you need to think about when you are thinking about angles in radian measure. This arc halfway around the circle from the positive x-axis to the negative x-axis is pi radians. So if we're looking at something halfway in between, that would be 1/2 of pi radians, which we typically write as pi over 2. All right. If we want to keep going, well, coming down here to the negative y-axis would be 3/4 of the way all the way around. Or another way of thinking about that is that's this halfway around that is pi, and then 1/4 of the way around, which is pi over 2 on top of that. And 1 plus 1/2 is 3/2. So this is 3/2 pi, which we'll normally write as 3 pi over 2 in radians. And if we want something in between, we can do that using the same kind of logic. Again, remember that halfway around the circle is pi radians. Halfway there is pi over 2. If I wanted to break that into quarters, well, then you have pi over 4, and you have 3 pi over 4, right? 1/4 of the way, half of the way, and 3/4 of the way from the positive x-axis to the negative x-axis. Don't let the fact that the pi is written in the numerator confuse you. Think about this as 1/4 times pi. Thinking about it as the fraction times pi is a lot easier to understand, but by convention, we always write it as pi over 4. Likewise, you could break the distance into thirds or into sixths, which is the common way of dealing with things. So if I have something like seven pi over 6, right? Again, the first thing I'm thinking about when I'm looking at a measurement like this is that halfway from the positive x-axis to the negative x-axis is a measurement of pi, or 1 pi if you'd like. So 7 pi over 6, or 7/6 pi, well, 7/6 is 1 and 1/6 as a mixed number. All right, so here is 1, and then I need to break this into 6 and take one of them. So there is your 7 pi over 6 angle.